What up? Um, so this video is video number 6, and this kind of carries on from what we talked about earlier with oxidation and reduction. Okay, so we mentioned earlier that glucose gets completely oxidized during respiration, during aerobic respiration, and what that means is the hydrogens come off. Okay, so glucose gets oxidized, but whenever there's an oxidation reaction, there has to be a reduction reaction. So the molecules that get reduced as glucose gets oxidized are these guys right here. So NAD and FAD, or our good friends NAD and FAD, as I weirdly like to refer to them as. So NAD and FAD, NAD and FAD. Okay, so in your notes, well, first of all, NAD and FAD, they're hydrogen acceptors. So these are accepting the hydrogens that come off of the glucose. Okay, and when they accept those hydrogens, they gain energy, and eventually, basically, what's going to happen is they're going to take those hydrogens to a certain pathway in the respiration, and when they drop them off, when they release the hydrogens, they're basically releasing lots of energy, and that's the energy that's going to make most of the ATP that gets made in respiration. We're going to learn a little bit more about that later. Okay, so in your notes it says during cellular respiration, compounds are oxidized, giving up hydrogen atoms. So glucose is what mostly gets oxidized, but as I can't talk, you're going to find out that we take that glucose and we actually start splitting it apart. So it's glucose or the products that are formed from the glucose. But basically, they're all going to get oxidized. And for oxidation to occur, other compounds must accept hydrogens and thus be reduced. NAD and FAD act as hydrogen acceptors, completing the oxidation reduction reactions. Okay, so NAD. You can see there nicotinamide adenine dinucleotide. Yeah, I'm not going to ask you to write that out. I could barely even say it. I had to practice before I made the video. And FAD is flavin adenine dinucleotide. Okay, so both of these guys are known as coenzymes, which basically means they do help reactions to occur. They're basically helping respiration to occur. Okay, so they're known as coenzymes. They're not a full enzyme. We're not going to get into too much of the differences, but they're known as coenzymes, and each may accept a maximum of 2 hydrogens. So basically, FAD and NAD, they can accept 2 hydrogens. So NAD can either become NADH if it accepts 1 hydrogen, or NADH2 if it accepts 2. Can't accept more than 2 though. Basically, it's full when it accepts 2. Okay, so and both of them can only accept 2. So letter D says, as the hydrogen atoms are transferred to NAD and FAD, these coenzyme molecules gain energy because they are carrying extra hydrogen. You can see that basically in this little schematic that I have here, energy and 2 hydrogens. So basically this is energy that's coming from the glucose and 2 hydrogens coming from the glucose or products as glucose is broken down, so you'll see some of them later. But basically, that energy and those hydrogens get added to the NAD, and so get added to the NAD, and you get NADH or NADH2. Okay. Then later, the hydrogens are going to come off, and you release that energy and hydrogens, and then that's when later, when you release them, that's when that energy then goes into making ATP, which again we're going to talk about later. Okay, so NAD picks up hydrogens, becomes NAD or NADH2, depending on how many it picks up, and then later this NADH2 or NADH goes out and drops off those hydrogen, and the hydrogen then are used. Eventually, the hydrogen connect with oxygen to make water as one of the waste products. Okay, so you can see these equations. Now, I didn't do all of them. You do have them all listed on your notes there. it says the energy gain is temporary. In another series of reaction, the coenzymes will give up hydrogen and return to their oxidized forms. A loss of energy occurs. But another oxidation reduction transfer will be completed. Okay, so you can see some of those summary equations there. The reduction of NAD and reduction of FAD, and then oxidation and oxidation of each. Okay, so you can basically NAD gets reduced when the hydrogen get added and gets oxidized when the hydrogen get removed, and that's true for NAD and FAD. Okay, letter G says during oxidation reduction reactions, energy transfer with the hydrogen may be used to form ATP from ADP. So the energy that is picked up by NADH eventually is going to be used to make ATP, to basically transfer and add a phosphate to ADP and make ATP. Okay, and hydrogen will be transferred in this biochemical sequence. So basically hydrogen gets picked up and is transferred until the last step, which we're going to talk about later. It's called the electron transport chain. And at that point, oxygen acts as the final hydrogen acceptor and forms water. Okay, so you can see the summary equation there. Basically, you have glucose with hydrogens on it. You break off those hydrogens, you release some of that energy. Sometimes the energy can immediately basically go to making ADP to ATP. But normally what happens is when you connect the hydrogen onto the NAD or FAD, they gain energy, and then you can kind of see as the NADH and NADH2, as they lose those hydrogens, then that's where energy is going to come from to take ADP and make ATP. Okay, so you can see that basically glucose gets oxidized and NAD and FAD get reduced, and eventually when they get oxidized, when NAD and FAD get oxidized, that's when your ATP is created. Okay, so that's it for this video. Please stay tuned for the next.